Yes, it does. Okay. Oh no. Anyway. So just did the first one there. Pretty simple enough. You can use the base 10 because we know it's the natural log, so it's base 10. We can do that on both sides to get rid of that. That just becomes x minus 3 s 10 to the fourth, and that's pretty simple. And then if I remember correctly, since these are all the same base, you can cancel them all out, but I wasn't sure about that. Is that true? Do you know?
I remember our last assignment, that's what they did. If you remember the log 4, log 3, log 2, they just kind of kept canceling the log 2s out.
That makes
I
sense.
think we can only cancel one log 2 out, and then you have to solve the log.
Yeah, if it were log base 2 x times log base 2 x plus 2, and then 2 log 2, it would be different because you could cancel out both of the logs, but there's only 1 log and 2 logs on the other side, so you can only cancel out 1 log.
That's what I was thinking.
Like this. Makes sense.
But is it minus?
How's times? You're right.
Yeah, because that complicates things if it's minus.
Let's see. Oh. So.
Then you could divide x by both sides.
That's true.
Actually, to be honest, I'm not so sure because what we do to one half of the equation, we do to the other half of the equation. So if one half of the equation, we're dividing it by log, or we're canceling out a log. I guess doing the inverse, and I guess to the entire other side of the equation, we would do the same thing.
Yeah, kind of like this one, the first one we did up here. What's that? Where'd James go?
I don't know.
That's weird. I guess we could do it like we did up here. 2 log of x plus 2.
Do we have
equals 2 to the plus 1, I guess.
Can you multiply both sides by logs again to cancel them out? Or would that make it too difficult?
No. Darn.
Sorry, it got real funky for me just then.
So we were doing a little bit of what we did up here with these, just down here. See if that might work. I think, yeah, that gets rid of this log right here. So would we just use the natural log to get it kind of like 2ln plus 2, and then put that in parentheses, equals 2ln.
Couldn't we also just use the substitution method? Because they all have the same log base. So couldn't you use like ux times ux plus 2 equals ux, or 6x plus 1. And then you'd get the answer, and then you would
Log.
solve whatever log 2 u, or whatever that is.
We could try that.
Are we trying to solve for x? Is that kind of what we're trying to do?
I thought we were just trying to complicate things and have fun doing it.
I was just like, I'm trying to figure out what my end product should be. So I guess we're solving for x.
Yeah.
Y.
I'm going to go grab my notebook and a pencil real quick. I'll be right back.
Okay. Interesting. I'm going to keep going on the one at the bottom, the one that we already started. Okay.
So that's what x equals 1/5.
Doing it this way, but this was the other way, the substitution, where you use u.
Okay, so we haven't done that yet.
No, I just continued doing this until.
Till I got back.
Yeah.
No wait.
Um, so when you divided this u over here, when these u's cancel? Or this one, I mean. Taking this one and putting it over here.
If you say what now?
Second. So I'm trying to divide this u of x over here to get it on this side.
Uh-huh.
And when this u and this u cancel out
Yeah.
to make this.
Yeah.
Okay. Get rid of these parentheses, make things confusing. Well, at least on that side. Maybe. Yeah, I don't know what you would do from here, though.
Well, in the first step, instead of canceling out the ux, are you able to combine like terms and multiply ux by ux plus 2? Not combine like terms, but just multiply it out. Or does that complicate things? I don't know. Tell me I'm doing it wrong, and then we'll just stick with x equals 1/5.
We can just leave it as x equals 1/5, honestly, because we have all this to do.
Tons more.
I like it. Let's go. Onward.
Yeah. Okay, and then there's this one. And the trick here was to put this 2 to the x squared by using the log rule. That made all these natural logs the same, and we could drop them all at once and then algebraically solve. Use the quadratic formula. That makes x plus radical 3 or x minus radical 3.
Looks good to me.
And then this one's pretty easy too. Make this one equal to the log of this divided by the log of that. That's all through. So it's pretty simple. Now we come to this. I believe we have a formula for that. I wrote down on my notes.
And 2, 3, and 4, all of these are part of the. They're not part of the. We don't have a group quiz today, do we?
No, not till Thursday.
Okay.
E equals D plus R.
Times RT.
Yep.
Nice.
That'll help us to solve these a lot quicker.
Oh, I was looking for that equation.
After 10 years, if compounded continuously. So our A would be the 5,000, right?
Uh-huh.
And then P.
Are you sure A would be the 5,000?
No. It's
P's 5.
P's 5,000. We
Yeah,
want to know.
All right, P's 5,000. We're trying to find the A.
Principal. So I mean, there are four different problems here. We could each solve one of them because when you stick them into the equation, they're relatively simple to solve.
Oh, I see. I thought this was all. I thought number 2. All of these numbers were one problem. I was like, how are we
No.
supposed to put all this into one equation?
A, B,
Yeah.
C,
Okay, I get you.
E. That's not.
Gotcha. No, my bad.
There we go. So what would R be? I'm just.
R is the rate, which is
That's
0.056. And the 1, so that 1 stays 1. And the 4, where did you get the 4 from?
it's not yearly. It's quarterly, not yearly. That's what I thought. You have to update that for. It'd be 1 if it was yearly, but then quarterly it's 4, and monthly it's 12.
Let me check. There were 2 equations that we learned how to do, and I was only good at one of them. So
How long will it take?
no, there's another equation that we have to do. It's not because the A equals P1 RT. That's for the compounding, not quarterly, but that's the constant one that's always compounding continuously.
Oh, which one's the new one? Do you know?
It's geez, I can't find it on this paper. I was like so proud when I found it the other day before I started doing the test during the homework. Oh, here it is. You ready?
Yeah.
A equals P parentheses plus or 1 plus R over N.
That's what it was. Yeah, I remember that now.
And parentheses, and then the exponent is NT. Because I remember that one never changes, but there were more things that we needed to put into the equation. So there it is.
Yeah. Okay. So that says to be a 1.
Yeah.
And this is over 4. And this is over 4 as well. Correct? Is that right?
Yes.
Okay.
Because the N is the number of times per year.
That is compounded.
Yes. And
Oh, wait.
T is, I don't know what T is.
T is time.
T is time.
10 years. That sounds easy enough, I guess.
Yeah. So then we just solve for that.
Does somebody want to take the first one?
I just got B. I got 115.42 years.
115.42.
Yeah.
I'm going to go back. I'm going to get my calculator real quick and check that. So I don't like using the graphing calculator for like graphing things because obviously that's like not fair. But like with this sort of stuff, it's so easy to just plug it into a graphing calculator.
Sounds good to me.
You can do it. Fine by me.
Oh, you had $400 initially.
Yeah, it's 400 initially, so
1 plus.
it's quarterly. So well, never mind.
Yeah.
I guess you're right. Yeah, sorry, never mind. Keep going.
T. Yeah, you wanted to know T in this one.
Yeah.
So you said T equals
Yeah.
Okay, so no, it's there's no divided symbol in the exponential. It's multiplying.
Oh, it's multiplying?
Yeah, in the exponent. So it'd be 4 times 10, so it'd be with an exponent of 40.
Oh, there we go.
The answer to number 1 is 8,719 and 43 cents.
8,719 with 42 cents.
43.
43 cents.
Yeah.
Oops. Okay. This is what A equals. Okay, let me see about the next one.
Good old $6. That's what I'm talking about. That's a good investment right there.
Who invests $6, honestly?
How much would you like to invest? I'd like to invest $6, please.
Like our grandparents investing in stocks. It took us 3 months to get $6.
That's true.
Oh gosh. Anyway,
Yeah.
so
Parents, I know we all live in jail.
18 equals $6. 1 plus 0.05 and divided by just that as it sits. Oh. And then we want to know what T is. And then this last one.
On these, do we round 2 decimal places? I can't remember.
Yeah, because you have to. They're asking about dollar amounts. So you round it to the cents.
Right.
These are like so much easier to me than the other stuff that we've done, just because I'm a financial economics major. So like, this stuff is just what I've been being taught how to do since day one.
It's
All
like
right, then we'll let you carry us from here on out.
Don't do that. Okay.
whoops. 2,000 million equals 400 times 1 plus, we don't know what that is. R is. And we know what T is, 200.
So for C, I got about 22.5.
2.5?
22.5.
2.5.
I guess if we're rounding to 2 decimal places, it's 22.52. Not that that would matter too much, but you know.
Yeah, just yeah.
Oh, that's incredibly easy.
$2 million? Holy smokes.
Now that's like a legit investment, man.
I know. That's better than the $18 goal that the other guy had after 22 years of waiting. Just went to work for a couple hours. The interest rate.
Let me do this.
After 200 years? I wonder if you could make an investment for like your triple great grandchildren where you just put in a bunch of money and let them compound it for 200 years and then let them take it out for whoever's the next in line.
Yeah.
And
It's one way to make your family rich real
it's not
quick.
as simple as like that. I mean, you could just put in stocks and just let it sit there forever. But you could also just like, I don't know. It's easier if like your grandparents do it for you. It's harder to do it for multi-generations, but you can.
Yeah.
But you can do it from grandparents to grandchild, like stupid easy, just through their will. And transfer it.
Oh boy.
Hey, how do you write down like logs, like to put it into something to get it solved, to make it into a log base? How do you put it in the base section?
Like on a keyboard?
Yeah, like on a keyboard or like on a calculator. So on mine, it's only allowing me to do like natural logs, like log 10. But if I put it in like that, then it's not giving me an answer that I necessarily want. So like, how did you guys solve C?
See, I just put it into the formula. That's all I did. And then divided it by T.
Well, I mean, so we can also, I mean, where it is right now, basically, we can change it into a log and just solve it for the log. I'm just trying to figure out how to do that.
Oh, I don't know how to do it through a log.
Well,
I'm
I
not
mean,
very good with the logs.
through the logs, it's super easy because all we have to do is take 6 and then parentheses 1 plus 0.5 and change it over to the other side. So it would be log base 6 times parentheses 0.05 and then of 18.
You can try it. Will that work?
I mean, yeah, it will work. I'm just trying to figure out how to make it into a base part on like a calculator, like an online calculator or something like that.
Do you have a TI-84?
Yeah.
I haven't used one of those for a while, but I believe what you do is you press the log button, and then you should have a little button that has it looks like 2 squares, a big square and then a little tiny square. Click that button, and it should allow you to change the base. If I remember correctly, I could be absolutely completely wrong though.
Trying to find those squares.
Let me look it up for you. Apparently there's a log base command. In your menu location, you press alpha, then F2, and then
Alpha
arrow
and what?
down to log base.
What the heck?
Were you saying alpha and then what?
It says go to your menu location, press alpha, whatever alpha is, then F2.
Then F2?
Yeah.
What the heck?
The heck?
I don't like that.
And then you use your arrow keys to move down to log base.
Oh, I found it. Oh, sweet. That's awesome.
Do we have to use a different formula for this one? Because I can't figure out how to solve this R1 for some reason.
I've been trying to do something. I'll show you what I've been trying to do. I think we might have to because
Oh, this, I just looked up a different formula and they used your first one that you had where it's, they did A equals P times 1 plus RT. There's no exponent.
uh-huh.
And so it'd be R times 200, and then maybe you can solve it that way. I don't know. It's just what I saw for another formula for it.
This is the way they did it in the help me section of my math lab, so I'm guessing that's the right way to do it, but
I just looked it up using the formula I told you, and what they came out with is 4,989 over 2,200. Which, when you solve that, the rate equals 2.27%.
which seems reasonable.
Yeah. Because what they did, it made a lot more sense when I looked it up doing it this way. What they did is they basically just divided you don't have the exponent of 200. So what they did is they essentially just divided the 2 million by 4,400.
Sorry,
I'll just
what did you say?
share it for you. So when I put it in as this formula where they did 1 plus R times T, then they switched sides, and then they divided it by the 4,400, simplified it, so then you only have 1 plus 200R over that. And then if you subtract 1, you get the 4,000, that one. That doesn't make sense. Shouldn't that be 999 when you, 1 over 1? Shouldn't that be 4,999? Oh, well. And then they did that, and then they just divided it by the 200, and that gave them R.
So what was the original formula then?
It did A equals P times 1 plus RT.
Wait, hold it up. Repeat that again.
So they did, hang on, let me look at I'm not on Google Hangout anymore. Oh, wait.
I guess you should put.
Where'd you guys go? I lost you. There it is. So they did A for this D. They did A equals P times 1 plus R times T.
That?
And then they just put the 200 in there, and then you can just solve it. You just divide by your P, and then, follow through with everything else. Track the 1.
Should be A and 1. And this would be times 200.
Oh, you find the least common denominator. That's why they did that.
So what did you say the rate was?
You're trying to find your rate right now. So it's
Yeah.
just R. And then you times it by your T, which is 200 for 200 years.
Okay. Oh, okay. I got it. I got it.
Then you just divide it by 4,400. You're 2 million.
Okay. 4, 5, 4, 5, 4, 5, 4, 5. That equals 1 plus R times 200. Then do we subtract the 1 over?
Yeah, and then you subtract the 1. I'd just copy that whole equation basically and then just do it 453. And then you divide it by that 200 and you'll get 2.27%.
Minus 2.
Oh, that makes sense. I was trying to figure out why it was a different equation, but it's not, because in the equation you would put R over N, and N is 1, so it's just R anyways.
Yeah.
Oh, that was awesome.
That should be 453, right? Because you're only subtracting 1, right?
Yeah. Whoops. I must have said 2.
No, you're good.
Bar times 200. Okay.
And then you divide by the 200 basically.
$2.26, yeah. That
Well,
makes
it's
sense.
2.27 when you round.
That's true. There's a 5 at the end, yeah. Oh boy. Oh.
So then I'm gonna put that back in the equation to make sure we get the same answer. But you guys can keep going on.
I know it's good. You're good. I'll do something like that too.
Three. So 3 is just kind of giving us an example that you can use multiple things, right?
Yeah, you just look at it real quick.
So do we have to solve for x on these, or is it? I guess it's already solved, right?
It's already
Or do they
solved.
want us- Yeah.
You're just supposed to look at it and just, know that there's multiple ways of solving things.
Yeah. Okay, so then all we gotta do left is half-life, right?
Yeah, just these 2 problems, A and B.
And then we can go ahead and check, and we're done for the day, I think.
Yep, we are done for the day.
It's a glorious thing.
No
I
kidding.
just hope it doesn't take 2 hours again.
That was so horrible.
This one we just gotta find the half-life
Of carbon-14.
formula, right?
Yeah, you gotta know the half-life formula. And the half-life formula. Let's look that up right now.
So they have here for it is A equals. That's kind of weird.
What the?
They have n base 0 times 1/2 raised to the t over t1 or t divided by a half.
That sounds right.
But they have 3, but I don't know. I don't know the difference between the 3.
Wow.
That one looks like that. The one you've got right there, the A. Yeah,
That's a lot simpler.
I like that one.
Let's go with that one.
Let's go.
So it's
Pepper.
A. Let me write this down. A equals A to the 0th.
0.
Well, let's change that because why do you use the same letter? I mean, that just makes it confusing. So F.
All that's doing is like the final amount versus initial amount.
Yeah, so I'm just changing.
They use the same exponent because it is the same exponent. It's just it'll be a different number when you solve it. You know, like x and y are 2 different variables, 2 different things, but with half-life they're the same. That's why they use A0.
Just trying to confuse us.
Yeah.
Okay, I'll change that back then.
Well, it's okay. As long as we know that, no, it's just symbolizing that it's the same number. As long as you know that finding the half-life of the same thing, you're okay.
Okay.
How did you guys think you did on the exam?
Got 100 on the first part, the multiple choice, but that one's easy.
I hated that. I missed one and I was so mad.
Did you?
Same.
The very first problem threw me off so bad. I had to like reread it like 12 times. The one where it was like, if A is the negative, does it cross the x-axis or does it bounce? And I couldn't remember which one it did. So I took a random guess on it.
Mine was
I was so mad. You miss one, you get a 75. It's but I don't
So
want more questions, so like I'm caught in that catch-22.
Yeah, no joke.
All right, the half-life of the carbon-14 is, whoa, that's a lot of time for a half-life.
So the half-life, that'd be your first A, which is 5730.
573.
Oh, wait.
No, wait.
Half-life is H.
Little H.
Yeah, so it'd be 3. So it'd be 0.1 is equal to 3.4.
Where are you getting 3.4?
Because it's
3.4
in
grams.
the equation.
Yeah.
3.4, and then we change that to differentiate it from the rest of the problems. There we go. Times 1/2. Oops.
Raised to 5,730 for T, right?
Yeah, T over 5,000. So.
T divided by 5730.
Well, how does that work, though? Because it says that we're trying to... Oh, never mind. Never mind. Might be. I'm with you. Keep going. You're right.
I don't know why there's 2 questions, though. That's what's confusing me. The half-life of carbon is that. How long does it take carbon for 3.4 grams of carbon-14 to reduce to 0.1 milligrams of carbon? And by radioactive decay, what is the difference?
Maybe that's where we have multiple equations.
But isn't that what half-life is, radioactive decay? That's what I thought. Maybe not.
Thought it was, too.
I was just trying to be more specific.
I think it's just wordy to try and throw you off.
Stupid math people trying to put in words.
I know. I really hate it. Just give me my values. Tell me T's this, Y's this, A's. Let me plug it in.
Oh, gosh. Okay. If 15 grams of radioactive waste reduces to 10 grams. So if we have 10 equals, gotta differentiate.
Wait. There's like, so you know that simple picture that we just saw that gave us the equation?
Yeah, what about it?
Like two columns down from that, there's another picture that has that same equation, but it being applied into an actual problem where we don't have H.
This one?
What?
This one right here? Or
Yeah.
where is?
Yeah, so if you go down a little bit, I don't know if it's going to be on that page. Yeah, there it is right there. But that's where we have H.
Oh, yeah.
Oh, so they change it to a natural log then.
Which makes sense. I will just set up this word. Oh, this time, the second one we have the time. Just not the other half of it. Divided by H, right. Okay, and what we want to know, both of these is, so we have,
So for the first one, you can just divide the 3.4 over, can't you? It would be 0.1
yes.
0.4 equals half times T over, your regular equation.
Let me just do that real quick. Zero 0.029 0 point. Oh wait, just kidding. Just kidding.
It's just 0.1 divided by or over 3.4.
Just trying to do several steps at once,
Oh, gotcha.
Equals,
And that equals the natural log of 1/2, and then raised to the p thing.
raised to the
T over 53,000 or 5730.
5730. Okay. And that throws right. Remember that. This is all the same. And we have T divided by 5730 over ln of 1/2.
Yeah.
And I guess we can multiply T to get it on the other side.
Can you just multiply it by 2 to get it to the other side?
No, it looks like you just.
There by itself.
It looks like you could just
divide it. Because in the example they have H, so the bottom one, which you would multiply it.
Oh.
But since we only have the numerator, not the denominator, or since we have the denominator, not the numerator, we have to divide it.
Gotcha.
Weird.
Does that make sense, Chris?
I'm trying to get it straight. So you want to divide?
Divide the left side of the equation by T.
Yeah. That's making a little sense to me. And we have 5730 ln.
So it should be natural log 3.4, right? And then over natural log of 0.1? No.
So, oh, I see where you're going. I see where you're going. So it should be 5730 natural log of 1/2 that whole thing divided by natural log of 0.1 divided by divided by 3.4.
By H, do you mean T?
Yeah.
Yes, I mean T. Yeah. Okay. Let me type this into a calculator. Five, 730. Natural log of 1/2 over natural log of 0.1 divided by 3.4.
All right, I got an answer, Chris. What'd you get?
I'm about to find out right now. 1,126.
Yep.
Yeah, that's what I got too. So T equals 1126.
That wouldn't work though,
3.
because the half-life is 5,000 years, and so it can't be the total time is only 1,000 years, right?
The half-life of carbon 14 is 5,000 years. Okay.
I'm gonna check on the tab and we'll see what they get.
Yeah, no kidding.
They got 29,151 years,
Which makes a lot more sense.
which would make sense that the other one's 5,000 years for a half-life.
Where did we screw? They put LM instead of LM.
Maybe that's where we got it wrong.
Oh, so it's actually.
So
you don't even
they
need-
just solved it, and they just put natural log of 1/2 over 5,730.
Oh, wow.
What? What?
That's what they got for their final one was natural log of 1/2 over 5,730.
Let me see how that works. That doesn't work.
That doesn't work. It doesn't come out. Well, that's what they got for their K. They said their T is that. What's the K? Do we even have a K in our X? In our...
I don't. No, we don't.
Oh,
So what's K?
I'll try. Oh, maybe this is the one we were supposed to do. There's a K right there.
There is a K and a T, but
And this looks like what she got for her answer. The form that she had her answer in.
yeah.
So perhaps.
Well, here comes the 2-hour session again.
What? Oh. And
boy.
because there's the E there, that makes sense that why she used the half-life.
Yeah.
Or not the half-life, the natural log.
So A of. A of. It should
So
have been
A times time, so the time we're trying to find, right?
after.
So we'll have two T's. So we have A times time equals A, E, K times time, which I'm assuming K is half-life.
Oh, wait a minute. What? Oh, we don't know what the initial time is.
Yeah, that's what I'm saying.
That's confusing. So the original is 3.4 E to the KT. What is K though?
I'm assuming K is half-life, which is at 5,730.
5,730 times what?
I don't know, because where do you get where's the 0.1 come in for, you know? I'm going to plug this into Symbolab and see what they come up with. And then maybe that'll help us understand it. I think understanding is a little better than just guessing and checking and hoping we get the answer.
Yeah.
You kidding me? That's like the only way to do math.
Guess, check, and hope. Okay. So here's how the thing did it. I just did our original one because I didn't know where the 0.1 came in, but it made sense with ours. And then they got 2,951, right? Or 29,151.
Yeah, that was the answer that Sister Hess or whoever did the website gave.
Okay. So it looks like, okay, so they just multiplied by 10 to get rid of the decimals. And then they refined it.
Cool.
Then they divided both sides by 34.
To get rid of
So I
that
got them,
34.
yeah, to get rid of the 34. So I have 1 over 34. So this is what the actual equation comes out to be. 1/2 times t over 5,730 equals 1 over 34. And I took the natural log of both sides. Then they applied this rule. Oh, so they took the half out and the 134 out, and I'm assuming they're probably going to multiply. What? Oh, so they just multiplied this 1/2 onto t. So now they have t natural log 1/2 over 5,730 because they just multiplied the fractions. Then they simplified it. Get negative natural log 2. How do they get natural log 2? This log rule?
Apparently.
I'd never known to do that. Then simplify it. And then
A lot of steps that I had no clue that we were supposed to do.
they applied the same negative log rule to this to get rid of the fraction. Apparently, if you have a natural log of a fraction, you can just take the negative inverse of it and get the denominator as a whole number. That's what they did here is they took the negative natural log, which gave it to 2 instead of 1/2, and they did that with 134 to get 34. And then somehow got t out of this. Oh, so they multiplied both sides by 5,000. That's how they did it. So they multiplied both sides by 5,730. And then they just had to divide the -2 over. And then that cancels the negatives out. So that's how they did it. And that gets you the 5,730 natural log 34 over natural log 2. Does that make sense to everybody? I think there's a lot of steps, but it's just because it's explaining it. I kind of understand it a little better. All they did was they just got rid of all the fractions by doing the negative natural log, and then they just literally multiplied and times everything out and divided it over. I'll look at graph if you want it. So, is there any part anybody wants to see more of?
There's like, I want to see less of all of it, to be honest.
Okay, here I can do less.
I'm like, Chris probably wants more.
Hide steps, hide steps, hide steps, hide steps. That's it. There you go.
The insanity.
Yeah, so it makes sense that they just did this because they literally just got rid of everything that was on the outside. Once they got to the natural log, that's all they really did. And then they just got rid of the fractions by multiplying it by the negative natural log. And then they just divided everything out.
Crazy. So how'd you even begin to put that into the equation?
I have no idea.
Oh, what is that? Wait,
There it is right there.
at the top?
Yeah.
So it'd be 0.1 equals 3.4 over 1 half is t over 5730. Ooh, Snapchat.
Ooh.
And then, let's see, where are you at so far writing this down?
I just did the first line right there.
Oh. And then I think we could honestly, you can jump to just do the 1 over 34, this one right here.
Honestly, yeah.
Well, actually, you could do this one instead.
Yeah, that one makes more sense.
Because that's just, I need to divide it out.
1/2.
I'd just copy that t over 5730 because you're going to use it a lot, and that's kind of a pain to type out.
Such a pain. So we have the 1/2
raised to the t to the 5730.
Really?
It might not work actually if you're trying to. Oh well. We understand what's going on. And then just do equals 1 over 34.
1 over 34.
And then they took the natural logs, and so from there we could probably do this equation.
And that is this. This again. This.
Times natural log of 1/2 equals natural log of 1 over 34.
1 over 34.
And then you can do this on the left side right here, because all that actually you can just do this equation. All I did was multiply it by the negative.
Oh.
So it's negative natural log 2 times t divided by 5,730, which equals negative natural log of 34.
So incredibly complicated.
I know. And then what they did is they multiplied both sides by the 5,730.
So it would be right at the bottom there, yeah.
Yeah, essentially. Well, there's two steps. What they did was they times both sides by 5,730, and then they divided it by the negative log 2. So
Gosh. Divided by ln of 2.
and then that gets you
How that?
all of that.
Oh my gosh. Okay, let's power through this. Let's get this last one done. Power through it. Okay, do we even have the equation set up right then? I don't think we do.
Well, that was they used the same equation that we used last time. So because this one doesn't have a t either. Wait, no, does it have a t? Yeah, it's got after 100 years. We're trying to find h on this one, right?
Yeah.
So what I'd start off doing is just the same thing what they did is I'd divide the whole thing by 10, so you'd have 15 over 10.
Okay.
Or 1 over 5. Or no.
It'd be 5 over. No, not 5 over 1.
2 over 2.
Wouldn't be 2 either. I think that's as simplified as it can. Oh, 5. So it'd be 3 over 2. It'd be 3 halves.
Yeah.
Which equals 1/2, and then the 100 times h. And then they took the natural log of both sides. Natural log, so it'd be natural log 1/2 times 100 over h, because that gets rid of the exponent. And then you can times it by natural log 1/2 over 1/2 and make that into one side into a fraction. You know what I mean?
Can't you just take the negative inverse of, or just the inverse of natural log 1/2 to get inverse log 2?
Yeah, you could. But you'd have to do the net inverse of 3 halves, which would that just be 2/3?
Yeah.
So it'd be negative 2/3 equal, or negative natural log 2/3.
Natural log of 2/3 equals
Negative natural log of 2.
Of 2 times that.
And that'd be times 100 over h.
Okay.
Now we have to get 1 natural log to the other side and h to the other side. So would we just divide the left side, or divide both sides by negative natural log 2/3? So it would be negative natural log 2 times 100 over negative natural log 2/3 equals h.
What? Oh, can you
It
say that
would
again?
be.
Hmm.
How'd you get equals h? What did they do in the one above when they had this? Because this is the same thing. Let me look again. Because they multiplied natural log. Let's see. I'm just going to use theirs so we don't cheat again. Yeah, so they multiplied it through. So,
Did they?
yeah, I'll show you. I'll screen share again so you guys can see it again. So what they did is so here's where we're at right now on our problem.
Mm-hmm.
And so if we do what they did, essentially, it came out with natural or negative 2t over 5730. So ours would be negative natural log 2 times 100 over 8.
Negative natural log. And you said
2 times 100
over h.
over h. And then we just have to get rid of the top of that. So you'd divide. So then times both sides by h. Get rid of it on that side. That makes
What is
sense?
And where's
So after you multiply it, because you have negative natural log 2 times 100 over h, you multiply that by h to get rid of it. And then that would equal negative natural log 2/3 over h on that side. Does that make sense? Or not over, but times h.
Oh yeah,
Times h. And then you can divide your negative natural log 2/3 over to the other side, and then you have it simplified in h. So you'd have h equals, and then this would just be positive because it's a negative over negative. So it'd be natural log 2 times 100 divided by natural log 2, or yeah, 2/3. And then we just got to solve that.
brief. Oh man. Natural log of 2.
I got negative 170.95.
You shouldn't have gotten a negative because it's both things a positive fraction,
Well,
right?
Let me see.
no, I agree. I shouldn't have, but I don't know why I did.
ln of 2.
Hi, baby. Divided by natural log of 2 divided by 3. You got negative 2 somehow. I got negative 170.
Same.
Yep.
Hmm.
That's the answer?
I don't think so.
Yeah, how can negative be it can't be negative.
Look, but we have the same numbers. 170951. We're just off a decimal place.
Wait, they by 1,000. Where did they get the 1,000 from?
Oh, you know what they probably did? I don't know, because 100 times 100 is what? 10,000?
Oh no, 10 times 100 is 1,000.
Oh, so they probably multiplied both sides by 10 in order to get rid of the fractions.
They have a different problem. They have 15 grams race reduced to 10 grams after 1,000 years, and we only have 100 years.
Did I write that
Ooh.
down wrong?
No, oh yeah, we did. It's 1,000. So everything's the same. We just got to divide it by 1,000 then.
We got it, guys.
Did we? Woohoo! But why is ours negative?
Just
Who
multiply
knows?
by -1 and call it a day.
We have the numbers.
Yeah, we're supposed to leave it in inverse. Let me see if we left it as negative inverse.
If you have one negative inverse, it comes out as a positive.
So maybe we weren't supposed to inverse the 2/3 and keep it as 3/2.
Oh, yeah. You're probably right. Does that change our number? Because they did the inverse, because they have 2/3 for their natural log.
Oh, they do.
But when
But
you
when you do it as 3/2 or 2/3, it still does the same. It equals the same.
so I wonder if if we're supposed to leave it the same fraction, but like you're not supposed to do negative inverse of both sides.
Here's the thing, though. If you do natural log the same way we did, with both as a positive, you put 3/2 in instead, it still comes out. It comes out as a positive instead of a negative. It's a positive.
ln of 2/3. That's not even correct right there. Or K, as they called it. Let's keep it as H.
So I think we're well. I don't know how you'd get rid of the negative though.
Nope.
But we have the right answer. We just have it negative somehow. Which to me shows good work that we were on the right track.
I'll buy that.
Yeah.
I mean, if we came out with the right answer, we just somehow got it as a negative. I guess we could. Do you want to put it into that calculator that I had and we can see how they did it?
If you want.
15 equals 10 times 1 divided by 2.
Yeah, it's weird because if you leave one of them negative, you still get negative 1,709.
1,000 over.
Yeah, that's what they're saying on the calculator too.
They came out with a negative here too, though.
Maybe
Could it
you
be?
have a negative and a positive answer, and you're supposed to only keep the positive answer.
Well, they would have listed that too. Could it be possible that she's just applying logic and saying there's no way you could have a negative 1,000?
Well, I don't know, because even if this play, even this calculator came out with negative. We did everything right, though. We've got all this right. Except for they didn't do they didn't do the inverse natural log of 3/2. They just did the inverse natural log of 2.
Yeah.
But everything else we did right. There's a natural log. They simplified this by getting the inverse over h. And then they multiplied that over, I think. Multiply both sides by h, which we did. And then divide by the 3/2, which we did. Then when you simplified it, h equals 0. It's saying that there's no answer because this comes out as negative. That's what that's saying. Because when you plug it back in, it equals 0.
Oh, yeah. That's what it's saying.
It's saying because it's negative, there's no to find.
A faulty problem.
Ooh.
I don't know. We did all of our steps right. We got the same answers. Just don't know why theirs is positive.
I'm at the point where I'm just blaming the problem.
Yeah, it's something's written. There's a negative. That's common to happen too.
15, 10, 1,000.
15, 10, 1,000. Yeah. So
Did
I'm
we
just thinking.
Did we? Oh, why is it? Why do we have the half? Where'd the 1/2 come in from?
Because it's
Half-Life?
Yeah, it's the original formula.
Okay. Well, since we did it correct, I'm going to say that we understand it and it's the faulty problem.
Yeah,
I agree. I'm gonna agree with him.
I'm calling it good.
Because we did this one by ourselves and we came out with the same answer, you know?
Yeah.
So I'm going to blame it on a faulty problem.
And
Sounds
on
good to
that
me.
note, sweet.
Okie dokie.
Alrighty, well, we'll see you all on Thursday.
Oh, I was almost gonna. So I was gonna do that thing where just the member was showing.
Do what?
The what now?
Who was it last time? I had like the windows just arranged for just this guy's face was showing, and it kind of scared somebody last time. I was gonna try to do that again, but oh well.
Like it didn't scare me. It was just startling because I was like trying to figure out what we were talking about on the page, and then out of nowhere, I see this Hispanic guy.
Jeez.
Me.
Anyway,
Anyway,
so I
see you
guess
Thursday.
yeah. See you guys Thursday.
See ya.